Hello dear friends. So today we will start with the first lecture on our course on indoor air pollution. In this lecture we will cover the introduction and also have a look at the common indoor air pollutants that we can encounter in a indoor environment. So indoor environment is of course very important. Chances are when you are looking at this lecture you are doing it from an indoor space. It can be your classroom, it can be a living room or a hostel room. There is a high chance you are looking at this lecture from an indoor setting. So people actually spend up to 90% of their time indoors, and this could be in houses, in offices, in schools, universities, other places such as shops, saloons and gyms. And it's important to know that house means house in is a setting, but within a house we also have different rooms. We have a bedroom where we are sleeping or lying on the mattress and turning around, or a bathroom, or a living room, or a dining room where there is furniture. Same for offices, you can have a big wide open office space or a small cabin. Schools, you may have lecture halls, classrooms, bathrooms, cafeterias, which are different indoor environments with a different indoor setting. Same goes for universities. And then shops, depend on which kind of shops, saloons and gym, which will have different characteristics in terms of emissions and the type of air there is. So we spend 90% of time indoors and a wide variety of environments. And another study, it has been found that within that 90% of indoor time, 70% actually is spent inside our own house. So that's a substantial portion of our daily time which we spend indoors, even in our own house. On this side, there's another study which showed that 88% time is spent indoors, 5% outdoors, and 7% inside a vehicle, which is basically a special indoor environment. But it's clear that we spend vast majority of our time in an indoor setting. So indoor setting is where we can expect to have a lot of air exposure as well, or an impactful air exposure, because we spend so much time indoors. So some of the indoor environments are cut off from outside or have a very poor ventilation. So this could be, for example, a studio or a cozy apartment which has fewer windows or has a very less relation to the outside air. So in this case, anything that is coming from outside or emitted inside has a high chance of remaining within the environment, because the ventilation is poor and the thing is cut off from the outside air. So there is less chance of cross ventilation and dilution. Now indoor air at the same time contains a wide range of substances. In our case we are interested in pollutants. So these are particulate matter, organic compounds, then inorganic compounds, and then also biological, bacteria, viruses, fungi. Each of these type of air pollutants have a very different set of source, behavior, fate and health effects. So if we want to better understand our own indoor air exposure, we must know or understand the behavior of these type of substances and the whole indoor setting, and have some idea of how to calculate exposure to be better able to design a healthier living environment. So what is indoor air quality now? So indoor air quality is basically the air quality present within and around the structure, which can easily go inside. So on this side we have the figure. For example, here we have the house and we have the yard where we can have pollens from the vegetation. Also maybe we have applied pesticide or herbicides and these can vaporize and then go through the window, or a person is walking through the garden and takes it with their shoes and takes it inside. And then we have garage, which could be a place to store paints or solvents, sort of a workshop. And you can have maybe some carbon monoxide, so that's a source. Then in especially older houses, one may have asbestos sheets or piping which had asbestos, so that will release some asbestos to the indoor air. Then in attic, places such as attic which are maybe less frequently cleaned, we will have more dust, and also maybe this is used as a place to store chemicals. So we will have chemicals in the attic. Then in bedrooms we may have dust mites, then maybe some pet material might be there if people have pets in their houses. In bathrooms we can have another different sort of setting, because we may have bacteria, mold, viruses, so that's the biological part. And then maybe we are also storing some cleaning material in those bathrooms, so they may have some vapor emissions. Sometimes you may even smell them if you are doing some cleaning. Then in kitchen we are cooking food, so we have smoke. Concomitantly we have gases coming in, and then we have CO2, and then sometimes chemicals as well. Living area, if it's a smoking area, then we have tobacco smoke. And if there are sofas, carpets, furnitures, we may have emissions from carpets, flame retardants, or some varnishing is there, and that's being volatilizing, and then we can expose ourselves to those kind of things. So even within a house, we have already here we have seen 7 settings, and then there may be, in depending on situation, there may be other peculiar settings also, special settings. So within this one house, we are already exposed to so many different kinds of indoor environments. So then a person who is living in this indoor settings is exposed to different types of air, and the overall thing is the indoor air quality, and it can be related easily now to the health and comfort of the person who is occupying the building or the house or the apartment. And given the complex scenario and the time we spend within this building, which was almost 90% or 70% inside our own homes and 90% indoors, this is identified as a very important or very urgent environmental risk to public health by the United States Environmental Protection Agency. So what is indoor air pollution now? Indoor air pollution can be defined as a chemical, physical and biological contamination of indoor air, which basically would mean the presence of the substance at levels meaning concentration, mass per unit time, mass per unit volume, uh, at that level for a sufficient time, very important, to cause exposure which can adversely affect the health, comfort or welfare of the person. So you know that the contaminant is present at a high level, and it is there for enough time for us to breathe it in sufficient amounts that it causes a health implication. So this kind of situation leads to a degradation of the overall indoor air quality. It has been estimated by the US EPA that an average person receives 72% of the chemical exposure at home. Very much can be related to how much the time we spend indoors. In fact, household air pollution, in this case it was through burning of solid cooking fuels, uh, was attributed to an estimated 2.8 million deaths in 2015. So that's a substantial number. So it is actually a global concern, and especially considering we have a lot of solid fuels and cooking in India as well, and in many other countries also. Another story in another study in the USA, it was reported that estimated 1.34 million office buildings had problems with air quality. So that's a lot of buildings, and approximately 30% of all office employees were potentially exposed to the health effects of poor indoor air quality. So that's like 1/3 of the workforce being affected with poor health, which of course then impacts their own health and the work productivity and the whole work environment as well. In contrast, so we know that it's an important thing, but only a few countries are establishing standards or guidelines for indoor air pollution. So we have guidelines, or many places have guidelines for outdoor air pollution, but indoor air quality many times is outside the regulatory framework, so probably it should also come within the regulatory framework going forward. So, given all this, of course, it is natural that IAQ has received a lot of attention in recent years. So, here indoor air pollution was ranked in US EPA's top 5 environmental risk to public health. We already have seen that as much as 90% of our time is spent indoors and almost 70% in our homes. Also, now more studies have reported and suggested that indoor air quality is maybe 2 to 5 times worse than the outdoor air quality. So it's even worse than outdoor. So we should be concerned about indoor air quality. And given our new building structures where we have more energy efficient buildings or more cooling, central cooling or AC cooling, there is sometimes less opportunity for less fresh air to come if the outside air is fresh. If it is not that clean, then it's even a worse situation. But building structure in general allow less circulation, so maybe we are going towards a worse indoor air quality or a non-ideal indoor air quality. So how did the interest in indoor air quality evolve? So when there was an energy crisis in the 1970s, there became a need to develop more energy efficient buildings. That means if you are heating or cooling a building, there are less losses. So in that sense, people started to make more airtight buildings with more airtight windows and the doors and the whole setting, so that the energy is conserved. So as a result, the air exchange rates with the outdoor fresh air were reduced. So in old less energy efficient homes, we used to have almost 2 changes per hour. That means in 1 hour, the volume of the room was changed 2 times. So every half an hour, almost the whole air was flushed out and replaced by the outside air. But in new homes, it is only 0.2 to 0.3 per hour. So that means only 20 to 30%. So earlier, within half an hour, the air was replaced. Now within 3 to 5 hours, it's being replaced. So now the pollutants have more chance to be within the room itself. So, earlier higher exchange rates diluted and cleaned the indoor air contaminants, but lower exchange rates in the newer buildings are tending to retain these indoor air contaminants. And then this kind of poor indoor air quality has often been linked to things or health terms such as tight building syndromes or sick building syndromes, which people report to have in such kind of constrained environments. So once we have this indoor air quality becoming concern, people started to study and note different air contaminants. So it started with particulate matter, dust, aerosols. Very easy to fathom that there is a problem with dust. So particulate matter. Then formaldehyde came into the purview because it is widely used and emitted. Then carbon monoxide, dioxide, then volatile organic compounds that are also widely used, then things like carpet emissions. Then people started to think maybe radiation is important, then allergens and molds. So over time, as you see, the list already kept on increasing, and now it is established that there are many contaminants. So we have like a very wide list of contaminants. We can classify them as gaseous, particulate or biological. So indoor air pollution simultaneously can be classified as gaseous pollution, particle pollution and biological pollution. So here we have an example of these common air pollutants coming in. So here we have pollens coming in, secondhand smoke can come in, and other outdoor pollutants. Then once we have here building materials and wood furniture, the building materials can have coatings, same with the furniture. So they can give off several types of volatile organic compounds and formaldehydes, for example. Then here bathroom is a very moist kind of environment. So we have higher chances of mold, spores, bacteria and viruses being host in the bathroom. So that's one place. Then here in the living rooms we can have like pet material, then mites and cockroach allergens, and then radiation gases such we can have gases leaking from the ground, maybe radon, we will look at that in a moment. Then here cleaning products are being used, so there again we have volatile organic compound emissions, formaldehyde, and then some other particulate matter from mechanical motion, perhaps from cleaning and other household products. And then in kitchen we have of course combustion gases from stove and carbon monoxide. So again wide variety of indoor air pollution being emitted within a house itself depending on the setting. So now we can broadly classify them as respirable particles. So that's particulate matter, then NO and NO2, CO, carbon monoxide, carbon dioxide, biological material, volatile organic compounds, semi-volatile organic compounds. We will have a look at them. Asbestos, radon. So we have made some broad classifications. Of course, the list, if you go in details, will be much more. So respirable particles now. So these are, you can say, dust. It can be thought of as particulate matter, and these would be your sizes that will bypass the nasal defenses. So you know the dust will go through the nose and then reach the inner parts of the lungs, such as alveoli. PM is a mixture of solid particles and also liquid droplets found in the air. So in one of the lectures we will look at aerosols. Some particles such as dust, dirt, soot and smoke are large and dark enough to be seen, but others are so small that you would need a electron microscope to have a look at them and to detect them. But so they come in a very wide variety of sizes. So in terms of an easy classification, we can have defined them as PM10, which would be PM with aerodynamic diameter less than 10 micrometers. So we are somewhere at this stage. The particulate matter has basically crossed our nostrils. Then we have PM 2.5, which are all particles with aerodynamic diameter less than 2.5, and operationally speaking 50% at 2.5. So here we see that respirable particulate matter, which is the PM 2.5, can already reach within the lungs here. So bronchial tubes, bronchioles, 2 to 3 micrometer, 1 to 2 micrometer. And then PM with aerodynamic diameter less than 1 micrometer and zero point 0.1 micrometer are our ultrafine and nanoparticles, which can go so deep as to the alveoli, which is the air sacs. So once we are inhaling, we are substantially hampering the ability of lungs to function. So very important. Then we have so many sources: fireplace, inside wood stove, gas heaters, tobacco products, and several more sources as well. Then we have an important thing, which is an environmental tobacco smoke, which is the smoke that comes from burning of a tobacco product and smoke that is exhaled by smokers. Now if you see a cigarette, it has so many components. We have methanol, which actually is also fuel. Then we have acetic acid, which is also in vinegar. Nicotine is there. Then toluene, which is actually a hazardous industrial solvent. We have butane, which is lighter fluid. Hexamine, stearic acid. Then we have ammonia. We also have benzene associated with it. Arsenic, carbon monoxide, cadmium. So it's like one cigarette has so many organic and inorganic substances that are hazardous pollutants, and so this is like a very harmful source of pollution. So environmental tobacco smoke basically comes from tobacco products, cigarette pipes, so first hand, and also we already know, and it is quite recognized, that second hand smoke is also very important exposure route for tobacco smoke. Then we have nitric oxide and nitrogen dioxide. So nitric oxide is a free radical with one unpaired electron. So it will react with ozone, for example, indoors to form NO2, and also it can react with oxygen and air under discharge conditions. For examples, at locations where we have spark or plasma creation to form NO2. So NO basically acts as a precursor to nitrogen dioxide in presence of oxygen. Nitrogen dioxide is a reddish brown gas, and it is dangerous in higher quantities. It's anyways a poisonous gas and especially dangerous in higher quantities, and it's also a precursor to the formation of nitric acid. So when we inhale this nitric acid, we are going to have respiratory discomfort at least. Then we have carbon dioxide, which is a colorless, odorless and toxic gas. It's quite similar to air in its molecular mass, which means it basically mixes freely in air and moves together with it. Wherever air is going, CO will go. It's impossible to see and can go undetected in indoor air. And at low concentrations, it causes fatigue and chest pains. Then it will start to impair brain functions and vision at medium concentrations. And then when we arrive at high concentrations, we will have very severe all these above symptoms. So CO is also a very dangerous gas. Then we have carbon dioxide, where high levels of CO2 indoors can lead to slow performances and cause health effects such as headaches. So CO and CO2 are classified as one. Then we have the volatile organic compounds. So this is a class of organic compounds which have high vapor pressure and low water solubility. So these can be emitted as gases from solids or as like liquid aerosols in indoor airs. Uh, so here we can have different types of sources. We have cleaning products being applied in the wall, and then over time, as the compound is volatile, it vaporizes and we sort of can inhale them, and that's why it's called a volatile organic compound. Then deodorant can lead to VOCs emissions. Then when we spray perfume or fresheners, then we have source, for example, in bedroom as well. When we make bed, we can also sort of release some VOCs. Then we have indoor cooking. So cooking smells and cooking material through cooking of different types of foods, we can have VOC emission. Then finally, VOCs can also travel from outside to inside through the window. So for example, here is listed as traffic fumes. So we can have different types of VOCs coming indoors. So here it's basically a wider list of different sources of VOCs. We have paints, air fresheners, aerosol sprays, varnishes, wood preservatives. We have perfumes and hairsprays. Moth repellents can do VOC emissions. Then we have cleaners and disinfectants, copying machines, faxes and printers. Then we have craft supplies which may have some paints, then carpet dyes and fibers. So these are a lot many of volatile organic compounds. Some VOCs we are going to list here. One important example is benzene, which is a colorless, volatile, flammable compound and also very toxic. It is emitted during construction and remodeling activities, decorations, furnishings, floorings and carpets. So some of these things may, in some cases, may have benzene component, and which will be then emitted to the indoor air. Then we have a class of compounds called polyaromatic hydrocarbons. Mostly they are related with combustion related activities, and these are quite carcinogenic compounds and also mutagenic compounds. So very dangerous class of compounds. One special compound is formaldehyde, which is again colorless but highly toxic and also actually flammable at room temperature. It is often used as a preservative, used in production of paper, production of antiseptics and cosmetics. Then fuel burning applications such as gas stove burning or kerosene burning can also emit some formaldehyde. Also, it is a component of cigarette smoke, as we have seen in the one cigarette example. So formaldehyde has a lot of sources in indoor air, and that is why, if you remember, after particulate matter, formaldehyde exposure or formaldehyde pollution was very quickly realized as a source of exposure to people via indoor air. Formaldehyde exposure can cause irritation to skin, throat, lungs, eyes, and at higher concentrations, formaldehyde exposure can also be termed cancerous. Sources could be again, so interior plywood, pressed wood products such as hardwood, fiber board. Then urea, formaldehyde foam insulations can have a source of formaldehyde. The nail polish things, nail polish products, some of them can be a source of formaldehyde emissions. Then we may have emissions from mattresses and clothing. Then glues and adhesives also can have formaldehyde component in them. So again, these are very different types of products. We have wood products, and then we have nail polish, which is a beauty related product, insulation, and then mattress and clothing, which is like a bedding and every person related thing. Then glues and adhesives, which are typical application. So a lot of sources of formaldehyde. Then after VOCs, we have SVOCs, which are the semi-volatile organic compounds. So these compounds are emitted to air and they are likely to become solids and liquids as the temperature is low. So they may be emitted, for example, in case they are emitted through uh, high temperature applications, then they will actually become solids or liquids. Otherwise also they have a lower vapor pressure, so they will try to attach to particles or partition between particle as well as air. Examples are flame retardants, plasticizers, then perfluorinated compounds, and then other oil-based products. And these can be found in different plastics, floors, and walls. Then we have another set which are pesticides. These are all the substances and mixtures intended for preventing, destroying, repelling, or mitigating pest. Hence the pesticide. And these can be, source, we can term them as insecticides, fungicides, herbicides, basically anything to kill different kinds of pests and disease. Sometimes also disinfectants. So once we spray them on the plant or plants, or spray them outside in our garden, some of the pesticides can vaporize and come through the window and come inside, or a person is walking on the garden and then carrying the dust indoors, and when it comes indoors it resuspends or volatilizes and then we are exposed to the pesticide. So this is a pathway of exposure. Then we have a couple of special cases. One is radon, which is an important radiation of natural origin. It's a major contributor to total radiation received by common population. It is generally formed, or it is formed from decay of uranium rich geological areas. Of course, some places may be more rich and some places will be less rich. So the radon concentrations activity will be lower. So radon exposure, for example, can happen in a house which is built on soil with naturally high radon. So here we have how radon can enter a house. So in this case, it is seeping through the soil to the air and then traveling from outside to inside through windows. It can travel from soil cracks through building cracks to indoors. Then it can, from, if it's in groundwater, through pumps, it can come in to the water area. Same through fracture bedrock and borewell, it can come to the indoor water collection system, and once it comes there through shower or drinking water or any kind of water use, it comes inside. Here it's just coming up and occupying the outdoor environment, and then through window here it can come inside. So there are a lot of ways in which radon from outdoor setting, be air or be soil, can come indoor, and then a person is exposed to radon exposure. Then we have asbestos, which was used widely because it was heat resistant and had a high fiber strength. So it had been used in building construction materials and also as a fire retardant. It's actually very highly toxic with no safe level. So asbestos in indoor air will be emitted from a asbestos containing material. For example, for illustration purposes, these can be like old sheets or old pipings which may have asbestos in them. And then this will emit asbestos in whatever amounts to the indoor air, and then we will inhale that. Then another class would be the heavy metals, which are a group of metals and metalloids that have relatively high density, and they are also potentially toxic. Sometimes some of them are toxic even at ppb level. So examples here are lead, mercury, cadmium, chromium, and arsenic. These heavy metals can be, you know, coming to the indoor environment through lead paste paints. So this is more relevant for lead. Then through exterior dust and soil, they are carried inside. Sometimes if there is mercury thermometer that breaks indoors, it can, some of mercury can vaporize. In some places, especially occupational setting, people may use mercury for purifying gold. So there, when you form mercury gold amalgam and you burn that, the gold is there and the mercury vaporizes and the person can inhale that. So that's more of an occupational exposure. Then and of course all of these or most of these are also industrial pollutants, so they may be in outdoor air, and then outdoor air infiltrates to indoor air, and then we inhale the indoor air. So this is how we can get exposed to heavy metals, and heavy metals also become a source of a class of pollutants important for indoor exposure. Then we have a completely different set, which are the biological contaminants, and these can include bacteria, molds, mildew, viruses. We can have animal dander, cat saliva, house dust, mites, cockroaches, and pollens. And as you can see, there are like a number of sources. So here we have pets, then humans themselves, maybe through skin, or when we exhale, we are also emitting some microbes out. Standing water, humidifier, ventilation systems can bring cooling coils in air cooling units, drip fans, then water damaged materials may be source of bacterial contaminants. We can have moist surface, wet or damp materials which can emit microbes. Coolers, hot water tanks, even our pillows and beddings can be a source of biological material because we are lying on pillow and bedding. Then house dust is there, high humidity region. Then we have insects, mites, cockroaches, pollens. So all these are different types of indoor biological contamination sources. It's a very wide variety. So in summary, what we realize is that indoor air quality is a result of a myriad of influences made by many types of sources. We have seen like furniture, carpets, bedding, shower, chemicals stored in garage or bathrooms, cooking. So we have so many sources, and combine all of these sources then result in a particular pollution concentration, which when existing for some time will be inhaled by us in substantial amounts and cause indoor air exposure for us humans. So this culminates the first lecture. In the next lecture, we will continue looking at the IAQ problem, indoor air quality problem, and go further on the sources. Thank you.